Okay, so did anybody find a pattern in the first problem there? What do you think? Multiplied by 3? Hands up. Did you find that pattern? Is multiplied by 3? Okay, let's try a couple. So somebody give me a number. 9. Okay, so 9, if I multiply by 6, becomes 54. If I add 4, it becomes 58. Divide by 2 is 29. And subtract 2 is 27. So yeah, so far okay. Let's try with one more. Sure. 99. Okay, I'm going to have to grab my calculator then. 99 times 6. Sorry? So you did this one too? Add 4. 598. And then 299? And is that still times 3? Okay. You like the human calculator over here? Oh, you're using your calculator, okay. You should have just lied and I'd have been impressed. Okay. So this is, again, that's inductive reasoning when we try to take what we're looking at in this problem with some examples and use our intuition to try to find a pattern. So we found 9 went to 27, 99 went to 297, and we thought the pattern is the end value is 3 times the start. So what we want to be able to do is use deductive reasoning now to prove that. Can anybody figure out how we might walk through the set of steps and prove that? All right, Paul, start us off. Okay, no problem. Joey, yeah? Okay, so you're coming up with, you're trying to explain the problem. What I'm looking for, which is, you're right about your explanation, I'm looking for a formal way in math that we can explain it. Okay. So you're going way, so Paul's already jumped way past the answer, so you're right, Paul. Let's just start with x for now, okay? So for choosing my number, let's just say my number's x. We don't know what the number is, but we're going to represent it with x. What we want to show is that when this is all done, we get 3x at the very end of it. So for step number 1, Paul, since it was your idea, tell me what I have. This is step number 1. That's right, thank you. Okay, anybody want to volunteer what's it going to look like on step number 2? 6x plus 4, yes. And step number 3, what are we going to get after that? So 6x plus 4, and if I divide it by 2, can anybody simplify that? Yeah, 3x plus 2. Everybody is halved. Okay, and then in position 4 there, what will we be ending up with? Yeah, subtract it, so we get 3x. So you can see that when I start with x, I end up with 3x at the end of it. So again, those are the 2 types of reasoning that we've been practicing. Inductive is when you try a bunch of experiments and you see what your patterns are. Deductive is when you're actually proving beyond any doubt that your pattern works for every possible number. Okay, so let's try this little puzzle here, and again we'll use inductive and deductive to try to prove it. So you're hosting a dinner party with 4 people. That includes yourself. So it's not 5, it's a total of 4. Everyone shakes hands when they arrive at the party. How many handshakes have been made at your party? Now, what I want you to think about is keep extending it. What if 5 people, 6 people? I'm going to ask you about 8 people. And by the time you get up to 20 people, you probably want to have found a pattern by then. Okay, so I'll let you guys tackle that problem. How many handshakes have been made at this dinner party? Okay, gang, let's bring it back up front here. So how many handshakes happen with 4 people? Okay, so I hear two answers, 12 or 6. Okay. Maybe this, let's just try something here. I'm going to say to Robin May, nice to meet you. How many handshakes just happened? How many people? Okay, so think about one handshake, 2 people. So it's not that my handshake counts and Robin's handshake counts. That would mean there were 2 handshakes. There was only one handshake that happened there. So if you had a group of 4, do you think there are 12 or 6 handshakes in total?
6.
Yeah, 6. So maybe we needed to be clearer, but there are actually 6 handshakes because that one handshake counts for 2 people. All right, did anybody figure out what if there's 5? There's actually more than 10. Oh, sorry, hang on a second. No, you're right, 10. 10 is correct. Need... Yeah, there would be 10. So did you find a pattern? Is that how you... 10 and a half handshakes? How do you do a half a handshake?
Like a high 5.
So 5 handshakes and a high 5. Yes. So that's what it was? Okay, how about, let me just think in my head first before I tell you. Okay, I got it. So how many people are there in with 6 people? 15 is correct. Okay, so those of you who seem to have either figured something out, let's see. Hands up if you think you have some kind of pattern here. Okay, just a few of you. So let's work out how we could do this. One really good way to think about it is a picture. I'll show you what it would look like in a picture with 4 people. So if I was to draw, I'll change the color. So here's the handshake. Let's say this is Bob, Alice, Carol, and Doug. A, B, C, and D. Oh. So what you have here is, this shows Doug shakes hands with Alice, Carol, and Bob. Alice shakes hands with Doug, Bob, and Carol. Right? It's trying to visualize it so that you know you've been able to count everybody in the room. Because if you don't, it's pretty hard to just count them all in your head. That's why a picture helps you organize all that information. So if you count, there's actually 1, 2, 3, 4, 5, 6 lines, 6 handshakes. So try and use the visual and see if you can figure out the pattern. I'll give you another minute before we talk about what the pattern is. Nick has something that we want to hear, so go for it.
All right, if you have 6 people, you count down 5, 4, 3, 2, 1, and then you add 5 to 1 all together. Like all those digits, you add them up.
So you went 6 plus 5 plus 4 plus 3.
No, you start at 6.
Okay.
And then all the numbers like below.
5 plus 4 plus 3 plus 2 plus 1.
Yeah, equals 15.
Okay. Yeah. Can anybody think of a way of explaining it with this picture? Yeah? Well, let me show you with this picture one way. One more time, can anybody think about how to explain what Nick does have a pattern there, and I've heard other people come up with that pattern too, but how would you explain it? It's a little trickier to explain this one, but I can show you with the picture how to explain what he said. Any ideas? So 3, in this picture, it would be, according to Nick, it's 4, 3, 2, 1, so it would be 3 plus 2 plus 1. Do you think, can you figure out how could you do 3 plus 2 plus 1 visually to show the rest of the class? What's he counting? Okay. Let me clear this up just so I can... I might have to put some more of these back on. Okay, so let's try. Here are all 6 handshakes. And according to the pattern so far, it was 3 plus 2 plus 1. So let's see, how would this work? Well, Doug shakes hands with 3 people. Let's not count them again. 1, 2, 3. Then Alice shakes hands with 2 people because we've already counted her handshake with Doug. 2. Then the only people we haven't counted is the handshake between Bob and Carol. 1. So that went 3, 2, 1. Or if you go backwards, 1, 2, 3. So that's what Nick's pattern, and I also heard it said on this side of the room too. But it's harder to find that explanation. There was another explanation for a pattern. Did anybody else come up with a different one? Okay, well, let's hear it. It works, and well, then it's not dumb if it works, right? Okay, tell us about it. X squared. Okay, let's start with a number then. 5 squared. Yeah. And then what? 6 squared? Well, shouldn't it work for all of them? 6 squared? Should we come back to you? Okay. Paul, what do you have?
First divide x minus 1 by 2.
Okay. Yeah.
And then multiply the products. Multiply the result by x.
All right. So hang on a second. Hands up. That pattern. Hands up if you had that pattern. I've seen that one in the room. Okay. So let's. Thank you for the pattern. I'm going to ask someone else. Do you want to explain it to us then, Kelsey?
So it's the total amount of people that are in like the room or that are shaking hands.
Yeah.
We'll have it and multiplied it by how many hands one person would shake.
Okay.
And then I divided it by 2.
So this is number of handshakes per person. So how come, like for example, when there's 6 people, how come you only shake hands with 5 of them? You don't shake with yourself, right? So that's why there's an x minus 1. And why do we say divide by 2?
Because there's multiple people and each handshake is with 2 people.
Oh, that's what
2 people per handshake. That's right. I'm just going to, I'll put that on the next. Nonsense. So 2 people per handshake, just like when I shook Robin May's hand, that was 1 handshake with the 2 of us. That's why we divided by 2. Yeah.
It's like the answer plus so 6.
Yeah.
6 plus 4 is 10 and then 2 plus 5.
Okay, so there's another pattern. So to get the next number, for example, to get 10, they found you go 4 plus 6. To get 15, you go 5 plus 10. So you can keep adding them up. That one's a great pattern too. But of all the ones we have, this one is the one that's easiest to go and find like the 100th handshake. Yours will work. It'll just take a while to get up to 100, right? So that one also works. And part of the reason for that, I think it would be able to explain it with a picture. But let's leave it for now with this one, which I think is a nice way of explaining how many people. You can't shake hands with yourself, and each handshake counts for 2. Okay. So here's some clues. What I want you to figure out is, this is just going to be a deductive problem that I want you to solve. Okay? What happens is, you've given all these facts about who's sitting at which table and who they're beside. I'd like you to show me what the actual, name the 4 pairs of partners based on this information. So it may help you to put some diagrams in and use the clues to eliminate them, right? So it says Dave and his partner were to the left of Stu. So you may want to, how would you organize this in a picture to try to figure out who the partners are? Okay, so I'm going to give you a few minutes to think about it. This is a deductive example because you're only using the facts that you've been given. You guys have one? Okay. Does anybody want to, well, why don't you just walk us through the first step and how you solved it? What did you do to organize this? Hold on a second, gang. I appreciate that you're involved in that problem. I just want to hear what Chelsea had to say. Okay, so you're using the first clue here that says when the game, so here's the first part that we're using. When the game was started, Dave and his partner were to the left of Stu. So how did you set it up then? Okay, Stu's here.
And then I put Dave to the left.
Okay, so and Dave is to the left. And then Sue is across from Dave. Okay.
And then you put Josh beside Sue.
So it says, yeah, it says who was to the right of Josh. So where's Josh? So Josh was here then, right?
Sue. That's Sue.
Yeah, it says here that's yeah, Josh should be here because it says Sue was to the right. Okay? So if we take a look at so far, there's a lot of information like you guys said at the beginning. Let's start crossing off some of the things we've got. So far we've handled Dave, we've handled Stu, we've handled Sue, and let's see, so where's Josh? So there's a better list. So we've handled Dave, Stu, Josh. So the people that are left are Angie, Tanya, Joy, Linus. And the next clue says Dave's brother. So who's Dave's brother?
Nobody knows.
Until the end.
It's Linus because he's the only boy left. So Dave's brother has to be Linus. Okay, so
That's a pretty weird name to begin with. You might as well just name it to a girl.
well, let's see here. Tanya, Joy, Angie. I don't think I've ever heard boys named Tanya. There could be, but I don't think I've ever heard boys named. And I'm thinking of Snoopy when I hear Linus. It is a weird name. But anyway, so I'm thinking guy's name is Linus. Yeah, so we know Linus and Tanya are together, and they're across from Stu. So Linus and Tanya can be put here. Okay, and then it says across from Dave, or no, sorry, Joy was not to the right of Stu. So of all the places, this is where the last set of people could be. And it says Joy was not on Stu's right. So Joy can't be here. Joy has to be on the other side. So this is Joy, and this is Angie. So now you can see your four partners, Linus and Tanya, Sue and Angie, Stu and Josh, Dave and Joey. Okay, so for the next activity, I have something for you, and it requires a fair amount of, let's see here, a fair amount of cooperation, I guess is the word I'm looking for on your part. This is a game called Leapfrog. You might have played it before, but I've got a sheet for you here that you can use, so you don't need to copy that one down. I also have the counters for you so that you can play Leapfrog. But when you play Leapfrog, there's a goal you have in mind here, and this is how you beat the person you're playing against, is you do it in the fewest amount of moves. So whoever wins the first game, think about how you did it. You go to the second game where there's 2 more squares. Try again. Whoever wins that one, you can tally it up. Last game here could be the best of 3. There is, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares there. So what I'm going to ask is that you come up to the front here and get one of these sheets, and that you get one of these bags of counters for you and your partner. Yeah, you only need one sheet per each, one sheet between the two of you and one bag. So if you've never played before, I just want to quickly show you how it works. What you do is one of you is going to be red, the other is going to be orange.
Or yellow.
So here's how you, or yellow, I guess, depending on your bag. Thank you. So here's how you set the board up to begin with, and you're going to play it one. What you have to do is one person goes at a time, and your job is to move all of these to the other side, and all of these to the other side. Okay, and what happens is you can move to either an empty square, or you can jump one other little tile, but you cannot move in any other way than to jump one tile or move into an empty square. So what I'd like to know is, what's the least amount of ways you can do this? That'll beat your, you do it, let your partner do it. Whoever can do it in the least amount, that's the person who's going to win this one. Then try the next level. We'll see who comes up with the lowest in the whole class. Let's hear, who did it the first one in less than 25? You beat 25? Okay, can anybody beat 20? Can anybody beat 18?
I got 18.
Can anybody beat 17? 16?
Wait, I'm trying.
Can anybody someone got 15? Anybody got 15 from Paul and Michelle? Wow, okay. 15 is the minimum that you can do if you play this game ideally. So I'm going to give you, I don't want to run out of time playing this, but I'll tell you something for a goal. 15 is the minimum for the first. 19 is the minimum for the second. So see if you can figure out the pattern that gets you there. And if you're really good, the minimum that gets you to the next one is 24. Okay, so see what you can do. So unfortunately, we're going to have to talk about the strategy and tutorial, so I'll let you mull it over and think about a strategy, but we'll talk about that strategy when we get to tutorial this week. But again, I'll just remind you that the fewest moves in the pattern above, it was 15, then 19, then 24. So tutorial, we'll leave it till then.
I got 20.
Okay, has anybody played darts before?
Yes.
So I don't know if you know how this is the game that they're playing is, the score starts at 501 and you keep reducing it. And then this is showing you how you get your points, doubles and whatnot, bullseyes and things. So right now you're dealing with Frank, who has the turn, and he has, I believe it's Frank's turn. And he has 36 is his score. He has to reduce his points by 36, while Tara has to reduce hers by 100 if Frank doesn't win on the next turn. So looking at this board game, can anybody give me a strategy? If you're Frank, how can you win? Because 36, he needs to hit exactly 36 points.
You can't go over. That's horrible.
So how could he do this? If you were Frank, where would he have to shoot for?
Or you can just shoot the 18 and then double it. It's 36.
Yeah, so you could go for, well, 18. If you doubled on 18, you'd win right away.
Yeah.
But I guess your next dart, you either throw it off the board or no. I just but what about how could you do it with 9?
Yeah.
How could you do it with 9? Two little parts. Yeah. So another way he could do it would be as if he ended up, say, here and here, he'd be at 36. He could do a couple of single 18s, so he could go there and there. So for darts?
Stop it, James.
Well, maybe I'll read the instructions one more time then. So it says, their scores are shown in the table. To win, Frank must reduce his score to exactly 0 and have his last counting dart be a double. So that means it actually wouldn't work to do two 18s because he has to have a double on his last turn. So he could do a 9 and an 18 because, double 9, double 9, 18 and 18 would work. That could be one of his turns. Maybe I'll write it this way. It could be 9 double, then 9 double. How else could he do it if he has to score a double on his last turn? Yeah, so the other way he could do this, an 18 and a 9, that's a double. Anybody want to come up with another one? Sorry?
I don't know. I'm just thinking to myself.
Just give me one more. How else could he win this game? 16 and a 10 double, so... Okay, yeah, that would work too. So if he didn't win and it was Tara's turn, how could she win if she still has 100 points left? Can she win on her next turn if she has 100 points left? So what's one way she could win? Sorry? Triple 20, okay. And then, well, if she got a triple 20, then what does she have to get if she on her next turn? That's 60 points. She needs to get it down to 100. Yeah, so she'd need a double 20. Last turn is going to be a double. Okay. Let's try one more. What's one more way that Tara could do this so that she got 100 points?
Bullseye.
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 Okay. So she gets a bullseye, but that's worth 50 points. And then,
Inner bull counts as a double.
okay, hang on a second. So you want to get, explain to me which bullseye, inner or outer?
Inner. Because then it counts as a double, then it's 100. Bam.
Okay, so she misses. And then
Miss.
her last turn, she ends up getting the inner bullseye. So that'll be 50, whoops,
Times 2.
50 times 2. Okay. Well, I was hoping to do, I know why we needed your counters. We won't have time. Yeah, let's try it. See if you can try the game with a partner on this one. I wasn't supposed to take your counters back yet, but the way this game works is there's a pile of 20 toothpicks. So for you guys, it's going to be the counters we were using, and you take turns. You can pick one or two out of the pile, and whoever has a one left on their turn is the loser. So what you're trying to do is whoever removes the last one, or sorry, this is whoever removes the last one is the winner. And you can only take one or two toothpicks from the pile. So you can't skip a turn. But you can say one or two from the pile. Okay, so my apologies, I'll throw some of the counters out to you to try that. Okay gang, let me just get you together for a second. There are only a few minutes left. So here's what needs to happen in that time. We will talk about the leapfrog, and I will bring these back. We'll talk about leapfrog, and we will also talk about this game in tutorial so that you guys can try to work out the winning strategy with me. But we're going to run out of time right now. So here's what I need you to do. First of all, I need you to make sure that if you dropped any of those counters, I hear them hitting the floor, that they all make it back in a bag, and that those bags make it up to me. Now the second thing is that we need to get this homework copied down. And this homework I'm going to collect from you, let's see here. Now this week is a funny week because of the end of semester. So why don't we just say that, I know you have Mr. Maloney's project as well. I will, as long as I get it before the end of the semester, meaning as long as I get it by Friday from you, that'll be fine. So again, we're not meeting up this week again for math because of your presentations and things. There won't be a specific math block for you to hand it in. So I'll collect it from you Friday before you do your presentations. I'll get them from the pile with you, okay? Does that make sense? Fantastic.